Hello. Yeah, the topic for this video lecture is friction, and we will deal with very basic principles of friction. So we'll get started with simplest example, which is a block on a fixed horizontal surface. The block B is placed on a fixed horizontal surface. Real life example could be box placed on a floor or book placed on a table. Now, what is the contact surface? As you notice here, there are two surfaces which are in contact, and one is from object B, another is from the floor. And as we know, whenever there is a contact, there are contact forces, and there will be two pairs of contact forces. First one, the normal reaction, N pair. The normal reaction will be perpendicular to the contact surface as shown here, and there will be another pair called friction force. And friction force will act along the contact surface. So this also along the contact surface, this also is pair equal and opposite along the contact surface. One is acting on object B, other one is acting on the surface in contact. And this is the direction, and the external force is acting towards right. What if we change the direction of the force? In that case, the direction of friction force also will reverse. We will later on see why so. So direction of friction force along the contact surface or tangential in nature. What if the surface is inclined? So here the block B is placed on an inclined surface. Again, there will be two pairs of contact forces. One of course will be the normal reaction, which will be perpendicular to inclined surface, and friction force. That pair also will be along the contact surface. Again, as you notice, one in this direction, other in the downward direction, equal and opposite. This is a friction force pair, normal force pair. So two pairs acting. So how do you find the direction of friction force? The basic property of friction force is opposes relative motion at contact surface. In other words, it tries to keep two surfaces together. What does keeping together mean? It tries to make the velocities equal. That's the basic property of friction force. It tries to make the velocities equal. So its direction will be such that it will try to keep the velocities of two objects in contact equal. We will start with the simplest example. The block is placed on a surface at rest, which is the most common one. And this is the force which is acting on the block. What is this force trying to do? The friction, it will try to make the block B move towards right. But the lower surface is fixed, which is at rest. What will friction do? Friction will attempt to keep the block B also at rest. Then only the two surfaces will remain together. So how do you analyze? Another way to analyze is something what we call as there is driving force, there is a resisting force. Friction force, of course, is the resisting force. How do you define driving force? In all cases, we will take x-axis along the contact surface. So driving force, let's call it as Fx. What is Fx? Fx is whatever forces are acting on the block. If we resolve into two components, x component and y component, so Fx is the sum of x component of all forces excluding the friction force. So that's a driving force. Fx indicates sum of x component of all forces excluding friction force. So on block B, the friction will always be opposite to driving force. If Fx is towards right, the friction force will be towards left. Thus on block B, and there would be a corresponding pair also. If we mark corresponding pair on the surface, many cases in typical problems, we don't mark this other pair of force, but this pair will always exist. In most problems, we don't actually show it, but this is the other pair. That's the direction. How about magnitude? To understand magnitude, let's imagine an experiment. The experiment setup is shown here, the block on a fixed surface, which could be ground. So the block is placed on a fixed surface, which is rough. And in this arrangement, a measured force can be applied on A by placing appropriate mass at B. So by changing the mass of B, we can change the force Fx which is acting on the block A, and we'll also know, if we know the magnitude of M, we'll also know the magnitude of force which is acting. So we can apply a measured force on A by placing appropriate M at B. The horizontal force Fx, which is nothing but tension in the string, this will be equal to M into G minus A. It will be M into G minus A being the downward acceleration. If this block B is at rest, or if A and B both are at rest, the tension will be equal to mg. So basically, as long as there is no slipping or there is no motion, Fx will be equal to mg, and if there is an acceleration downwards for B, it will be M into G minus A. So we will know the magnitude of force Fx, driving force. So let's start. Let's assume that initially the mass of block B is equal to 1 kg, and we found that block is at rest. So since the block is at rest, Fx, or the driving force, will be equal to M into G, which is 10 Newton. And given the fact the block is at rest, there has to be net force of 0, which implies the friction force also has to be equal to 10 Newton and in the opposite direction. Next, what we do, we increase the mass of block B. We make it 2 kgs. Again, if we find it is at rest, what does it imply? First of all, Fx will be equal to 20 Newton M into G. So this force will become equal to 20 Newton. And again, since the acceleration of block A is equal to 0, the net force in x direction must be 0, which again implies the friction force also must be 20 Newton in the opposite direction. So when Fx was 10 Newton, friction force became 10 Newton in the opposite direction. When the driving force became 20 Newton, the friction force has become 20 Newton again in the opposite direction. Suppose we continue and we find when we make M is equal to 3 Newton, the block A is again at rest, but just at rest. What does it imply? It gives an impression with slightest increase of mass B, the block will start sliding. So we call just at rest, or it is on the verge of motion. Since it is at rest, again the tension or Fx will be equal to M into G, which is 30 Newton. So this force is equal to 30 Newton, and given the fact that block A is at rest, the friction force also must be 30 Newton and in the opposite direction. So that would be the forces acting on block A in x direction. And if we increase the mass further, we make it 4. At 3 itself, it was at verge of motion. So when the mass is increased further and the force is increased further, the block starts moving, and through some measurement we find the acceleration of block A is equal to 1 meter per second square, or magnitude is 1. Since A is equal to 1, the tension in the string will be given by M into G minus A. So this will become 10 minus 1, it becomes 9 into 4. So Fx will be equal to 36 Newton. The force acting here will be equal to 36 Newton. And we can find the magnitude of friction force by applying F is equal to ma into x direction. So since the acceleration is 1, net force has to be equal to 10 Newton. Fx is equal to 36, it means friction force has to be 26 Newton. So what we find here, the friction force has been constantly changing. It increased up to 30 Newton, and when the block start moving, it has become 26 Newton. So what we observe here is very typical of what happens in case of friction. And the laws related to friction are based on experimental observation. It is not derived. So what we have seen here, this is what a typical of what really happens. Let's define what we observe here. When the block is on the verge of motion, that state is called limiting state. When the block is at rest or there is no relative motion, that state is called static state. And when the block here is in motion or there is a relative motion at two surfaces, that state is called kinetic state. So there are 3 possible states of friction: static state, limiting state, and kinetic state. So just let's have a quick look at the observations what we have here. In all 4 cases, one thing which has not changed is the normal reaction. Only the friction force has changed. Normal reaction has remained throughout as 100 Newton equal to mg. And what we found the friction force has gradually increased to a maximum and then it has decreased. And static state, limiting state, kinetic state. Let's analyze in more detail. So first, the variation of friction force F. As we increase Fx or driving force without change in normal reaction, the friction force or the resisting force increases up to a maximum. So if I plot the force which is trying to slide the block on x-axis, driving force Fx, and corresponding value of friction force on the y-axis, what we find in a static state, the relationship is linear. As we keep increasing the friction driving force, friction force also is equal and opposite. So it is equal in magnitude of the driving force. So from here the relationship is linear up to a maximum value, and which we call as F max or maximum friction force. And this entire state is called a static state. So let's see how do we define a static state. Block is at rest. That's a static state. There's no relative motion or no slipping. And static friction, the friction acting in this state is called static friction, and it opposes initiation of slipping. Is there any slipping? No, but it opposes initiation or beginning of slipping. So in this case, what is the acceleration of block B is equal to 0. If the surface is at rest on which the block B is resting, the acceleration of block B is equal to 0, and friction force is self-adjusting. As Fx keeps changing, F friction force also keep adjusting itself such that it is just enough to prevent slipping. In other words, since the acceleration is equal to 0, driving force plus friction force is equal to 0, or friction force is equal to driving force in magnitude, opposite in direction. And in static state, the value of friction force can be anywhere between 0 to F maximum. It is less than maximum value of friction force in static state. Its magnitude is not known. It can be anything between 0 to its maximum value. That is static state. What is the example of static state? Suppose a box is lying on a truck and the truck starts accelerating from a state of rest. So it means from 0 velocity it acquires certain velocity. If there is no slipping between the floor of the truck and the box, it means displacement of the truck and the displacement of the box are equal at all instances of time. So there is no slipping. So what kind of friction must have acted between box and the truck floor? Static friction. And that friction force magnitude would be less than maximum friction force which is possible. Now if we increase the driving force Fx even after slipping begins. So this is where the slipping starts, and suppose we keep increasing the friction force, keep increasing the driving force. If we keep increasing the driving force, what we notice, and this also is more of an experimental observation, by observing through some calculation we can find out what is the magnitude of friction force acting for different value of driving force. As the driving force keeps increasing, the acceleration will keep on increasing, velocity will keep increasing, but the friction force remains constant. So in kinetic state, when the slipping is taking place, the friction force remains constant. So let's define what is kinetic state. In kinetic state, the block B accelerates or slips. It means there is a relative motion between two surfaces which are in contact. Direction of friction force opposite to direction of motion, and F remains constant. It does not depend on velocity or acceleration, and we call this magnitude of friction force as Fk or kinetic friction. Example, suppose we slide a box on a rough surface. Friction will be kinetic in nature, and if we slide a box, what we will notice after some time will come to stop. It means its velocity will keep on changing, but all through its motion, even the velocity changes, the friction force magnitude and direction will remain constant till it comes to rest. So as long as there is a slipping, the magnitude of friction force for given normal component will remain constant. So what is limiting state? As we see from the figure, limiting state is the boundary line between the static state and the kinetic state. It's a boundary state between static and kinetic state. What does it imply? Slightest increase in driving force will initiate slipping. So first, it indicates it is on the verge of slipping. So what is the when it is in limiting state, what is the acceleration? Acceleration is 0. It is not, it is started slipping, or in this is when the lower surface is at rest. In general case, we can say the relative acceleration is 0. So acceleration of both the surfaces which are in contact are equal, same. And how about friction force? In limiting state, the magnitude of friction force is already at its maximum. So magnitude of friction force is known, which is equal to maximum friction force, and acceleration is equal to 0. These are the two important conditions related to limiting state. What is user limiting state? We may come across problems which use word like minimum force to make the block move, or maximum force that can be applied without causing slipping. So whenever we have words like minimum or maximum in a given problem, it would almost invariably mean the object has to be in limiting state. So all such question we can use the limiting state condition, which is acceleration is equal to 0, relative acceleration is equal to 0, and magnitude of friction force is equal to maximum frictional force. So what we noticed in previous slides, there are two important magnitudes of frictional force. One is maximum frictional force, another is kinetic friction force. Fx magnitude, maximum value of the static friction, and Fk is the constant magnitude of kinetic friction. How do you find the values of these two friction forces? First of all, both this Fmax and Fk depend on normal component of the contact force where the friction acts. So what is Fmax equal to? Fmax is equal to mu s time normal component, mu s time n, and mu s is called coefficient of static friction, and mu s depends on nature of two surfaces which are in contact. So as the value of normal component increases, the value of maximum friction force also will change. So, and how about kinetic friction? The kinetic friction is in a very similar way. Fk is equal to mu k times n. N again is the normal component of contact force, and mu k is called coefficient of kinetic friction. In most cases, we will find mu k or coefficient of kinetic friction is either lesser or smaller to coefficient of static friction. And if only one value of mu is given, we can assume that both the coefficient of frictions are equal. Mu k can be treated equal to mu k. How to find maximum friction force if mu s is given? First thing, whenever you have to find maximum friction force, first we have to find normal reaction. So every time we have to think what comes first, normal reaction first and first. Let's take a simple example. Here mu s is equal to 0.3. What is the maximum friction force acting on the surface? So first thing what we'll do, first we'll find the value of normal component of contact force. So Fmax will equal to mu s time n. First we should find normal component using summation of force in y direction is equal to m into ay, and since acceleration y direction is 0, summation of force in y direction is 0, and most cases will take x axis along the surface. So here the normal reaction quite easily will be equal to 100 Newton, hence maximum friction force will be equal to 30 Newton. So in a static state, the friction force will be anywhere between 0 to 30 Newton. Suppose we place another block on top of block A. So there is another block B we place on the top of block A. Mass of block B is 20 Newton. Will the maximum friction force between A and the ground change? Will the maximum friction force acting on the surface will change? Let's see how. As we place this block here, the normal component will change. Now the normal component, again using summation of force in y direction to be equal to 0, the normal component will become equal to 300 Newton. And since the maximum friction force depends on the normal component, the maximum friction force also will become 0.3 into 300 equal to 90 Newton. So what is 30 Newton here? Now it will become 90 Newton. So maximum friction force which can act in this case will be 90 Newton between A and the surface, whereas in this case maximum friction force was 30 Newton. What does it mean? So if we apply a horizontal force here, what is the maximum horizontal force we can apply without moving block A? In this case, if we apply the force would have been only 30 Newton. up to 30 Newton, the block A will not move. But in this case, we apply the force on block A, we can apply force up to 90 Newton and still the block A will not move. So driving force can go as high as maximum static friction. And by changing the normal component, the maximum static friction also changes. Let's take some simple examples to check the basics. They are very simple examples, and we'll try to apply the simple concept what you have learned. We'll find F max, maximum static friction, and what is the actual value of friction force which will act if it is static state. So this is a simple arrangement which is given in the figure. In this case, quite simply, again we will not find N will be equal to 100 Newton, and if mu s is equal to 0.4, maximum friction force possible in this case is 40 Newton. Let's take some other example. What happens if you apply a force equal to 30 Newton here? So in this case, summation of all forces acting in x direction excluding friction force is equal to 30 Newton, or driving force is equal to 30 Newton. How much friction force will act? I think with some common sense we can find out the friction force which will act will be equal to 30 Newton and block will remain at rest. Friction force equal to 30 Newton and would be static state. What if we increase the force to 40 Newton? So which are 30 Newton, we make it 40 Newton. What will happen to friction force and what state of motion this would be in? Here the friction driving force is equal to F max. What is that state? F will be equal to 40 Newton and that state is limiting state. With slightest increase in F, the block will start sliding. Now let's come to third case. In third case, there is another downward force of 200 Newton applied on the block A. Now the question is something similar to previous question. What is the minimum force I need to apply here to make the block A move? By now we have seen this force has to be slightly greater than maximum frictional force. To find minimum force which will move the block A, I need to find the maximum frictional force. What is maximum friction force? First thing we need to think of is the normal reaction. What is the normal reaction here? Normal reaction using sigma Fy is equal to 0. Normal reaction will be equal to 200 plus the weight. It will be equal to 300 Newton. Mu is equal to 0.4, hence the normal reaction maximum friction force is equal to 120 Newton. So what is maximum friction force? 120 Newton. So we need to apply a minimum force of 120 Newton or little more to make the block A move. So can we summarize what we have seen here? See, basically the state of motion depends on relative value of two parameters. What are those two parameters? Fx, the driving force, and Fmax, which is the maximum static friction force. If the driving force is greater than maximum static friction force, it will be kinetic state, the block will slip. If the driving force is smaller than maximum friction, it will be static state. Friction force will be equal and opposite to driving force, and it would be less than its maximum value. And if the driving force is equal to maximum frictional force, it will be in the limiting state. Acceleration is 0, friction force is equal to maximum frictional value. So let's move on to kinetic friction. So in this case here, suppose Fx is equal to sum of component of forces along x direction, which you have already defined along the surface. If this force is really large enough, how large? If it is greater than maximum possible frictional resistance or maximum possible friction force, then what will happen? The block will definitely move. In this particular case, we have taken mu k is equal to 0.35 and mu s is equal to 0.4. So first thing what you notice, mu k is smaller than mu s, which is typically normally the case. Normally, kinetic friction is lesser than maximum static friction, or mu k is smaller than mu s. Similar to maximum frictional force, magnitude of Fk depends on nature of the surface and the normal component of contact force, similar to maximum static friction. Fk or kinetic friction is equal to mu k times normal reaction, which you have seen earlier itself. So in this case, what will the kinetic friction? Kinetic friction will be equal to, normal reaction is here, normal reaction is 100, mu k is 0.35. So if you apply a force greater than 40 Newton, the block will start sliding. It doesn't matter what the speed is, what the acceleration is, kinetic friction will remain constant and its value will be equal to 35 Newton, which is mu k times n. So what we notice here, the friction force decreases soon after slipping starts. The maximum value of friction force was 40 Newton, which drops to 35 Newton soon after the slipping begins. So it takes a greater force to set the object in motion, and the magnitude of force required to keep it under motion is lower than the force required to set it in motion. So what are the typical steps to solve block on ground type of problems, simple type of problems? First, we draw an FBD assuming x-axis along the surface. Then we find the normal reaction using summation of force in y direction is equal to 0. Once we have the normal reaction, we can find F max, which is mu times normal reaction or mu s times normal reaction. And then we compare the driving force with the resisting force. So this is the order. The first, draw. Either we draw, you can visualize also. So we mark all the forces. We take the component along x-axis, y-axis, all forces except friction force. Fx is sum of x component of forces is the driving force, which is trying to slide the block. Y direction equation we give you the normal reaction. And once we have the normal reaction, we can find maximum value of friction force, which is mu s times normal reaction. If the driving force is greater than maximum friction, then kinetic state. If driving force is equal to maximum friction, limiting state. If the driving force is smaller than maximum friction, it is starting state. And in this case, the friction force will be equal to minus Fx. This is a typical sequence of steps to solve questions related to friction. Let's take a simple example. If external force is equal to 40 I cap minus 30 J cap is acting on the block as shown. So we resolve these forces. X component is 40, Y component is minus 30 or 30 newtons downwards. We need to find what is the friction force acting and what is the acceleration of the block. This force of 40I minus 30J could have also be given in form of force equal to 50 Newton at 37 degree with horizontal in downward direction. Both are same thing. Mass of the block is 10 kg, mu k is 0.3, mu s is 0.4. What you need to find? The friction force and acceleration. So force also could have been given as 50 Newton at 37 degree with the horizontal in the downward direction. Step 1, FBD, x-axis along the surface. We mark all the forces except friction force. So external force 30 Newton, external force 40 Newton, weight 100 Newton and the normal component. We have not drawn the friction force yet. Then from this diagram we find out what is the driving force in the x direction. Summation of all forces acting in x direction is equal to 40 Newton. There is only one force here. Fx is equal to 40 Newton. Then we find normal reaction using Fy is equal to 0. The normal reaction here n becomes equal to 130 Newton. Once we have n, we can find F max. F max is equal to mu s times n. Mu s is equal to 0.4. 0.4 into 130 is equal to 52 Newton. So maximum friction force which can resist its motion is equal to 52 Newton. So what we do? Finally, we compare the value of driving force with the resisting force. Here we find maximum friction force is greater than driving force. Hence, it will be in a static state. The block will not slip. And what will be the magnitude of friction force? It will be equal and opposite to the driving force, hence 40 Newton. Friction force will be 40 Newton and block A will be at rest. So this is the friction force opposite to driving force. Now second case, what we have done, we have just changed the direction of the force. Now the external force is 40 I cap plus 30 J cap. So 40 I cap, the component which is acting in the downward direction is acting in the upward direction. It can also be stated force is 50 Newton at 37 degree with the horizontal in the upward direction. This is more like a pulling force. Previous one was a pushing force, this one is a pulling force. Rest of the numbers are same. Let's find out in this case what will be the friction force and would there be any acceleration. If you recall, previous case, value of acceleration was 0. Again, the steps are same. First, we start with FBD, x-axis along the surface. We mark all the forces except F. Only change here is this 30 Newton in the upward direction. Then we find out the driving force, which is summation of all forces acting in x direction equal to 40 Newton. Then using Fy is equal to 0, no acceleration y direction, we find n here will be equal to 70 Newton. N plus 30 is equal to 100. So n will be equal to 70 Newton. So what was earlier 130 Newton, it has become 70 Newton. Normal reaction has changed. So maximum friction force also will change. It will be equal to 70 Newtons multiplied by mu s. So 70 into 0.4, it will be equal to 28 Newton. Now, finally, what is the state of motion? We compare maximum friction force with the driving force, resisting force with the driving force. Here we find the maximum resisting force is lesser than driving force, hence the block will slip. It will be the kinetic state. And since it's the kinetic state, the friction force acting also will be kinetic friction. It will not be mu s times n, it will be equal to mu k times normal component. So mu k is 0.3, normal component is 70. So friction force will be equal to 21 Newton. Hence, this is the friction force. So what will the value of acceleration? Acceleration will be, if we apply the equation in x direction, net force is 40 minus 21 and divide by mass 10 Newton. We will find the value of A for the block A will be equal to 1.9 meter per second square. So what you notice here, though the magnitude of force is same, previous case the block did not move. It was a pushing force. Now it is pulling force for same magnitude, the block moves. Because in this particular case, normal reaction is smaller and the maximum friction force also becomes smaller. It's easier to pull than push. So far we have dealt with a simpler case when the lower block of surface was at rest. Let's take case where the surface also in motion, or other way we can say the block B is placed on another block A, which is under motion. So lower block or surface A having velocity V. First of all, what would be the direction of friction force on each of the two blocks? Friction force will act in pair, equal and opposite pair. So first, which is the contact surface here? This is the contact surface. How many surfaces are here? Two. One for block B, another for block A. Now these two surfaces have different velocity. The top surface at rest, bottom surface having velocity towards right. So at the instance shown here in the figure, two surfaces in contact will have relative motion or they will slip. A will motion of A is towards right with respect to B. So if you observe from B, A will appear to be moving towards right, and similar way motion of B, if you observe from A, will be towards left. So what is the direction of friction force? Direction of friction force is opposite to the relative velocity. Since B is appear to be moving backwards, the friction force will act in the forward direction. So direction of one way to find the direction of friction pair is in terms of relative velocity is opposite to the relative velocity, or other way to find the direction of friction force pair is in terms of what should be the direction to make the velocity equal. This has zero velocity, this is velocity v. So here the friction force will try to speed up block A and friction will try to speed up block B, which is having lesser velocity, and it will try to slow down block A, which is having higher velocity. This will be towards right and this will be towards left. What is direction of friction force pair? To make velocity equal. Take the second case when both the blocks in motion unequal velocity. Again, what would F try to do? Oppose relative velocity, or friction force will try to make the velocities equal. How does it make it equal? It will try to slow down the object moving with the higher velocity by applying a force in the opposite direction, and it will try to speed up the object which is having lower velocity by applying a force in the same direction. So on B, backwards to slow it down, on A, forwards to speed up. Will act until both velocities become equal. So as it keeps slowing down, keeps speeding up, after some time both velocities will become equal, and as soon as the velocities become equal, the job of friction force is done and friction force will stop acting any further. So what is the direction of friction force again? Along lower velocity opposite to higher velocity. Same case is applicable in case of acceleration. If two blocks have unequal acceleration, it will be opposite to higher acceleration and along the lower acceleration. So this you notice, this is opposite this direction, same direction. That's the direction of force. That's another way to understand direction of friction force in case both objects are under motion. Let's take a simple illustration. There are two blocks A and B, with A having velocity of 10 meter per second placed on a smooth surface. So here the A is placed on a smooth surface, but surface between A and B has coefficient of friction of 0.3. So what would happen in this case? Again, we will take x-axis along the contact surface, along the horizontal direction. Let's analyze this question. First of all, where is the contact surface? This is the contact surface. Again, two surfaces in contact have unequal velocity. Hence, relative motion is taking place or slipping is taking place. The fact that slipping is taking place, the friction, it will be in a kinetic state, or friction force acting will be kinetic friction, which is equal to nu times normal reaction. The normal reaction very easily can find out is equal to 50 Newton. Hence, kinetic friction will be equal to 0.3 into 50 is equal to 15 Newton. So kinetic friction of 15 Newton will act direction on B. B having lower velocity, friction force will be in the forward direction, and on other block A, it will be in the backward direction. Magnitude of friction force 15. So block B will have acceleration of 3 meter per second square. Force is 15, mass is 5. Hence it will have acceleration of 3 meter per second square. And block A will have acceleration of minus 1.5 meter per second square. Why minus? Its direction is in the negative x direction. So there will be retardation acting on block A. How do you define minus 1.5? Force by mass. Force is equal to 15, mass is 10, and acceleration is 1.5 in the negative direction. So if these are the as soon as at this instance, this would be the acceleration of B and A. What will the velocities of B and A at t equal to 1 second? That should be simple enough. We can find velocity after 1 second using V is equal to u plus at. Velocity of B will be equal to 3 meter per second, and velocity of A will be equal to 8.5 meter per second after 1 second. Now what is the next question? When will both velocities become equal? At what value of time will the both velocities become equal? That also is fairly simple to find. At time t, let's say they become equal at time t. At time t, velocity of B is equal to 3t, and velocity of block A will be u minus at, 10 minus 1.5 t. So the value of t is 10 by 4.5 second. So at t is equal to 10 by 4.5 second, velocities become equal, and thereafter friction force will stop acting. Both will move with the same velocity. Friction force will cease to act. Moment the velocities become equal, its job is done. So that concludes this part. Thank you.